So I think it's question number 19 that you'll come across in the homework where you have something that looks like this. It looks at first, it appears to be pretty overwhelming to factor. But if you notice something about it, notice that it's got a perfect square leading coefficient. And then the last coefficient here is also a perfect square. That being the square root of 49 is 7 and the square root of 64 is 8. This is actually taking on the form of a perfect square trinomial, which we've looked at these formulas before, and they can be factored in this way. One thing I like to point out is that, this may be just yet another formula that you've got to memorize when you're dealing with special factoring. But just so you know, you don't have to memorize yet another formula. You can still use the same strategies that we've talked about before for factoring these things. So, for example, let's look at the factors of the first and the factors of the last. Now, let's just go ahead and try the square root of 49, 7 and 7 for the first, and the square root of 64, 8 and 8. Notice if we break these down, we do 7 times 8, we get 56. Then we take 7 times 8 again and 56. If we were to add these, notice we get 112, which is that middle term here, the middle term coefficient anyway, right? And that actually is the 2xy piece to this. So what we can do here is we can rewrite this in such a way that this right here looks a little bit more like the perfect square trinomial formula. So what we've done here is we've taken 7b squared, right? We've kind of done the reverse of the power rule. Then notice we have here the product of the square root of the first and the square root of the last here, 7b times 8d times 2 plus the square of the last. So what we've rewritten this to look a little bit more like the perfect square trinomial formula. So we can use the perfect square trinomial formula to move right into this factored form here, 7b minus 8d squared. But, if you don't like memorizing formulas and you don't like applying this, just use the same strategies, which we'll do next, that we've always done with these when we're factoring trinomials. So remember when we factor by the AC method, we would take these terms and then we would rewrite the middle term, right? Remember, we always rewrite the middle term, breaking it into two pieces because we're unfoiling again. So using the AC method, remember the next thing we would do would be to group it. So now we have a first group and we have a second group. So what we do when we're using the AC method, we would take out the greatest common factor out of each group. So the greatest common factor of this first group is 7b, and the greatest common factor out of the second group is negative 8d, which is what we do here. And again, we've created this common factor of 7b minus 8d. So we factor out the 7b minus 8d, and we end up here, which is the same thing as 7b minus 8d squared. So you don't have to memorize the formula. You can just use the same strategies that we've used before, such as the AC method here, to get to the same place.